Welcome to this video on dimensional modeling, which we'll use to get a mental model of our data and the data warehouse, how it should be structured and how we should build it. So in order to do that, we need to have dimensional modeling in the background. So using dimensional modeling to align the data warehouse to the business. So why do we do dimensional modeling? Well, it gives us a clear and visible business model. Data becomes more accessible in the organization as we'll include several users we'll include several stakeholders when we design our data and our dimensional models. Mental model of what to build. This is one of the most important, I think, is that you understand what you want to build, and then it's much easier to build something that will be useful for different stakeholders because you're serving the data to someone in the end. And it reduces the costs and the risks of your project, of your data pipelines, and as you choose, you kind of choose the business processes that are most that gives most return on investment, and also those that are most feasible. And then you model it in a way that that the data can support decision making. And it's very easy for querying, and the performance is also it will be helped through dimensional modeling. So this you will notice a lot about the query usability after we have modeled the data. So it's very easy when you serve it. So remember this data pipeline. I know it comes up very frequently in my lectures. So here we'll focus on the data warehouse part, and more specifically into the warehouse part. So remember before we talked about staging, where the data comes into the staging part using DLT in our case, where we have ingested the data into the staging part. Staging actually a schema then. And then from the staging schema, we take the data into the warehouse. And before we do some transformations, it's important that we know how to transform the data. So, and how we do that, we need to have a dimensional model. Dimensional modeling is part of data modeling, to be clear. So we model the data warehouse, the warehouse layer as star schemas. So this is one type of modeling. And this follows the Kimball approach. So Ralph Kimball is kind of the guru in dimensional modeling. So you should really check out his book if you want to learn more about this. So then you start with you create fact tables. And the fact tables represent, for each row, it could be a transaction, for example. Selling ice cream, then we have ice cream transaction as rows in a table. And then this table, we want to enrich this data somehow. We want to enrich it with different types of dimensions. Then you have the dimensions around it. So the dimension could be, for example, we have a geographic dimension, we have a date dimension, etc. So that these can be joined into your fact table when you're serving the data in the data marts and enriching the data. So and afterwards we will send this into the serving layer and the data marts. And in dimensional modeling, there's 4 steps that you need to know and follow. So you need to find a suitable business process. For example, a business process could be marketing, a business process could be sales, etc. And then you define the grain. So how should the data, how should one row look like? For example, does one row represent 1 month of sales? Does it represent 1 week of sales? Does it represent 1 day of sale or one particular sale? That is the grain. So it's important to define it and base your data on the grain. And then you identify the dimensions. Which are the dimensions that will enrich this data? What columns should I put in the dimensions? And you identify the facts. Which are the facts and which should go into the fact tables? And to find out the business process, you need to find out which business process the model. So it's the activities to achieve specific organizational goals. Activities, remember? For example, we have retail sales, we have store inventory, we have warehouse inventory, retail promotion tracking, retail sales forecast. We can receive warehouse deliveries, it's also an activity. And when starting, it's important to pick a business critical process and a feasible process in terms of data availability and quality. So for example, retail sales, it's very good to start with because it's critical, but then you need to check if the data is available, is it easy to use and take, and what is the quality of the data. So, and in atomic, in the grain, it's very important that you have more granular. So the more granular, the better. For example, a sales example. Each row represents transactional grain. Could be, we have a single sale. We have daily grain. It's a daily sale. And we have monthly grain. It's a total sale at monthly level. So the more granular, the better. Why? Because we cannot anticipate exactly what the business users want. For example, maybe they say that they want to have daily sales. That is enough for them. Yes, but what happens if 1 month later they say, no, I actually wanted to have per hour. Okay, then it's much harder for you. If you have the data in daily sales, much harder for you to go back to 1 hour. However, if you have the data in transactional grain, where you have single sale, this is the most granular you have. It's the atomic grain. It's easy for you to aggregate up to 1 hour when you have the date and time dimension as well. So you see, it's easier to slice and dice the data when you have a very atomic, when you have very granular. When you have the more atomic your grain is, the easier it is for you to meet different business requirements. And the business requirements, you can never anticipate exactly what the business wants. It changes a lot. Yeah, exactly. So low grain of fact is much easier to join to different dimensions, making it better at meeting various business requirements. And an example with dimensions now in healthcare. So dimensions, they are descriptive attributes that provide context for the facts. So, for example, in dimension tables, we could have date, we could have patient, doctor, hospital. And the descriptions could be like this. For date, we have day, month, quarter, year. Patient, we have patient ID, patient name, age, gender. And doctor, we have doctor ID, doctor name, specialization, hospital ID, hospital name, and location. So these are different dimension tables, which you can use to enrich your fact tables. And the facts for this healthcare example. So facts are quantitative data points for measurable events or transactions in a business process stored in fact table. So, for example, note that it must be measurable and it's a quantitative data point. So number of patient visits, for example, diagnosis code, and treatment costs. So these are the columns in the fact table. So for example, they could represent the number of patient visits, code representing the diagnosis, and cost of treatment in Swedish crowns. And the thing is, fact and dimension tables, they're linked somehow, right? And they're linked through something called foreign key relationships. So you have primary keys in your tables, and you have foreign keys, which are keys that are which are the same as a primary key in another table. So for example here, now I have dimensionally modeled this healthcare case. So we could have fact healthcare, and we see that for the doctor ID, this is a foreign key referencing this primary key in the dimension doctor, in the dim doctor. Similarly, hospital ID here is referencing hospital ID in dim hospital. And through this, it's very easy if you want to enrich the data set. You have the fact healthcare, and then you just join on the hospital ID on both of the tables. And in this case, you get an enriched data set. And one thing to notice here is that in star schemas, in contrast to in OLTP when you do data modeling, is that in OLTP usually you strive for normalizing the data, so you have third normalization. And while in star schema, however, you don't want to normalize the data, so you should stop normalizing. Instead, you have denormalized tables. Okay. So this table, you can, there's also another way of, you can normalize it further and make it into something called a snowflake schema. However, this is not very good for the business, because these dimensional models, the business need to understand also. They also need to understand how the data looks like. And through star schema, which is quite easy, it's very easy to understand that this is the fact, these are the dimensions, and which are the columns inside. We don't want to add another complexity to this. So star schema of the hospital example. Yes, thank you. And thank you, and see you in the next lecture, where we'll perform this dimensional modeling. And we'll do it in DBT, so data build tool. Yes, thanks.